Okay, hello everybody, and welcome to our new webinar at AIMS. In this webinar, Mark Govertz and Dirk Leinders from Hasselt University in Belgium will present the new Ontology plugin for the integration of controlled vocabularies in information management systems. I want to inform you that the whole webinar will take about 1 hour, and the presentation will take about 20 minutes. And afterwards we will have a discussion round where we invite you to ask all your questions. I also want to inform you that this webinar will be recorded, so you will have the opportunity to watch it again after the presentation. Okay, I think we can start now. Mark and Dirk, please go ahead.
Hello everybody, good afternoon, good morning, good evening, depending where you are living. So today we have presentations of work developed by students of Hasselt University. It's a work in a way finalized. It has a result as a tool, but it is also work in development. It is a work that has to be integrated and also can be further developed. So today it will be about integrating controlled vocabularies in information management systems, the new Ontology plugin. And my name is Mark Govertz, and I'm a librarian of the Hasselt University Library, and next to me Dirk Leinders, software developer at Hasselt University, is also here available. So today we will talk a little bit about the backgrounds of where the idea is coming from this ontology or vocabulary plugin, and simply a description of the concept, the implementations. Dirk will go deeper in the technical description, and then we will also give a demo and explain a little bit the next steps to take. So already a few years ago, FAO defined the terms for an AGROVOC plugin for Dspace. The idea to harvest, to use a harvest system for agris and having good authority control of AGROVOC terms was developed already at that time. And people of Hasselt University in Bangkok, Thailand, have developed a first plugin specifically for AGROVOC. And it was for an older version now of Dspace 1.4, and it has never been upgraded. But already it gave the possibility to work in a multilingual environment and using the AGROVOC vocabulary and its unique identifiers behind it. So we go to the next slide, and another development together with UNESCO IOC IOD and FAO was AgriOcean Dspace, to make a customized version of Dspace which support standards, richer standards in metadata, but also ontologies, thesauri like AGROVOC and ASFA. AgriOcean Dspace is in fact an easy to install version of Dspace, customized for the communities of FAO and of UNESCO IOD, and it has already different installations. At the moment, more than 50 organizations are using AgriOcean Dspace, mostly through Ocean Docs, but there are in the meantime, about 10 separate installations. So in that way, the standards are used through the whole organization, through the whole communities. Now, if we look at an important aspect of AgriOcean Dspace is the use of authority control. It is a customization of the authority control in Dspace, and in the way that journal titles, AGROVOC, ASFA are defined through authority control tools. It is in fact based on alphabetic list of terms and with auto-suggest possibility. The information, the data is in tables in the database and can easily be looked up. You see an example on the screen. Now, we stress more and more the importance of uniquely identified content. And not only ISSN, ISBN, digital object identifiers, URIs like used in linked open data. I think that's very important that we can identify in our metadata the content as much as possible uniquely. Also, geographical information can be well defined, and controlled vocabularies can be very relevant on that level. Also, from our experience at Hasselt University, you see that that in many communities, the need for different vocabularies become important, and support for many vocabularies is becoming more and more important. That's a little bit also the reason why, instead of looking only at an AGROVOC plugin, we were looking at a vocabulary or an ontology plugin who can support different vocabularies. So it's the ontology plugin in the first place is at the moment a tool used during submission of metadata. That during the metadata submission, that you can choose the right keywords, the right subject terms, the right author, the right geographical description. It can go in different ways. So in that way, it's not only a vocabulary. Sometimes it's therefore we use it the ontology plugin. So and vocabularies uses. When you use a vocabulary, you need to access all the relevant ones that you at the same time. You don't have to go through the different systems many times again. But at the same time, we only want to show the relevant ones. So it means that there is sometimes a grouping necessary depending on the content, on the user, but also on the type of ontology. As I said, for example, subject terms, you will combine an AGROVOC and ASFA with maybe a plant ontology, but besides that, maybe you combine geographical ontologies, like the one, the NERC one, for example, with other ones. So in that way, that's the reason why we have worked on an ontology plugin. The ontology plugin is an independent tool that can be integrated in different systems. It is a plugin, and it is in the first place created within the context of AgriOcean Dspace to be integrated in AgriOcean Dspace. And at the moment, we have the possibility to search the web services of FAO's AGROVOC, but also a specific server, an ASCOSI server, who harvest in fact vocabularies ontologies. And at the moment, we are using the AGROVOC ASFA, the plant ontology, but also on ASCOSI, Christophe Dupriez has harvested the Ocean Expert, which is an expert database, and from PubMed, the mesh ontology. Now, these are two web services already developed, but other ontologies can also be accessed, and the broker therefore has to be extended.
So I will mute. Okay, so I will now briefly describe the architecture of the Ontology plugin. The Ontology plugin consists of two components. There's a user interface and there's a search web application. The user interface is written in jQuery to create a responsive application, and the search web app contains the server-side code, and this is written in Java. Then, when the user clicks the search button, the user interface sends a request to the web application, and it does this for each thesaurus separately. That is, a search request specifies the name of the thesaurus, it specifies the search string and the language. The thesaurus web app will respond with a list of matching concepts from the specified thesaurus, and it returns this representation in a format SCOS RDF XML. Then the thesaurus search web app, it will delegate each request to a third-party web service, and then the result that it gets will be translated to SCOS if it is not already in SCOS. The third-party web service that the thesaurus web application will use is configurable via a Java properties file in the web application itself. Then, when the user interface receives the matching concepts for a given search, it will display only their preferred labels, and then the user has a possibility to click on a preferred label, and then the user interface will do a separate request to the search web application. It specifies the URI of the concept that is clicked on, and also the language, and then the thesaurus web app will delegate this request again to a third-party web service, and then it will include a representation of the concept, including the preferred label, and also the narrower, the broader terms, and the related terms. Then a little bit on the integration. The Ontology plugin can easily be integrated in any HTML page where you want the user to specify a list of concepts. To integrate the plugin, the only thing you need to do is to add some JavaScript files to your page. The JavaScript code that loads the main search window that you will see in the demo, this is provided in the file called overlay.javascript. This file will show the search. It contains the code that shows the main search window, and this is displayed in an inline iframe. So what you need to do is bind the code that shows the main search window to a certain event, like the user that clicks a button or a link. Then the parameters that you need to give to the main search window, they are the thesauri that you want to search in. So for each thesaurus there will be a different tab page in the center of the search window, and on each page, on each tab, you will see a list of results from the specified thesauries. Then, when the user clicks the save button, the main window will execute some function. We call this a callback function, and this is the second parameter that the main search window needs. So in this callback function, you can do whatever you want to do. So you just want to copy the selected concepts to your page, or maybe you want to create specific input elements inside a form that you can post to your web application.
Okay, now we are going to a live demo. If it doesn't work, we still have some slides to look at. But we are going... Okay, no, it's not showing. It's not shared. I have to share. It's my theme. Ontologies, this one. Yes, it's strange. Now, this is simply a demo page, and in fact, this is this should be in an application the page where you go and get the information from the plugin. So here we enter the plugin. You get also some documentation, some background information, some use information on this page. So this is simply the layout of the Ontology plugin, where you have an history, and you see we have at the moment we can look in 4 different vocabularies. This can be extended or limited depending on the needs. We have the search box, in fact, and the result box on the right side. So we are going to look for a concept lagoon, and we will see what the results are. I'm looking for it, and I see with AGROVOC we have 2 results, and ASFA has 3 results. We can go and look for, we have 2 terms, and if we click now on the term lagoons, we see the direct relations, the broader ones and the narrower ones. For example, coastal lagoons, and then you see the broader ones is again lagoons, but also the related ones. And yes, I'm interested in brackish environments, and well, simply in mangrove swamps, for example. I can also have a look at the same time what is in ASFA, and we will also look for lagoons. And here you see that ASFA has less structure, and you also can find the brackish environment in ASFA, for example, or the lagoon fisheries. Well, lagoonal sedimentation is an additional one. Okay, we can look a little bit further and go for flower, for example, and we search for the term flower, and then we see that you have in the plant ontology 21 words with flower, and I'm going to simply to the flower development stage, and well, I'm simply choosing. I'm not a specialist in plants, but I simply choose the flower development stage, something like that. You see, every term you choose you will find it back in the selected result. But okay, we can work further. You also can go back to a previous result in one of the ontologies, and for example, go back to the flower from AGROVOC, and there you see flowering stage, for example, and we see the plant development stage, and we add it again to the result. We have some information about geography. No, I will take the Pacific. Search. Then you see that you find results in AGROVOC and in NERC. The advantage of NERC is that it has in its description, you don't see it here, also the longitude and latitude information about the region. And you can, for example, link it to a Google application, a Google Map application, if that's something students have done in the past for us. And so we can say that in the South Pacific Ocean, I hope there are also some mangrove swamps there. We can add it there, and but also in AGROVOC you will find the Pacific Islands, and so we have, as a result, at the moment 8 terms in in all 4 of the ontologies we have been choosing. You can, if this is necessary, ordering it, putting it lower or higher in the ranking. Also, for example, this flower development stage, no, sorry, I am not interested in it. I remove the item from the list. So you have a list of terms, which is a result. Now, if we save it, we send back to the original application the results. You have them here. These are the terms we have chosen, and you get as a result at the moment the term, the ontology, and the identifier. It's you can extend it to a full URI if necessary. So in that way, this information can be included in another system. You have simply to write the way to accept this information in a mother system. And then you can choose for different solutions. If you think URIs are enough to separate AGROVOC from ASFA from NERC, then you work with the full URIs. But you also can put everything in different metadata elements. Having a metadata element for AGROVOC, for ASFA separately. It depends on the application that you are using. It depends how you want to interpret, make an interpretation of this information. Okay, this is a short presentation. We go back to the slides. Share, recently shared. Okay. But I will skip this page of the presentation and go immediately to the roadmap, because we are running out of time a little bit. So you see that in the first place, this tool has been developed, but AgriOcean Dspace 2.0, which will be based on the latest Dspace, but will have its own submission and workflow model, will be available in the beginning of next year. At the moment, the tool itself is available for other projects on Google Code. At the end of the presentation, you will find the addresses. Now, this is a project which has a result at the moment, the tool itself, but we are interested in further developments. For example, at the moment, we show only the direct relations of a term. You have seen lagoon and you see specifications of lagoon, the broader and the narrower terms of it. But it would sometimes be interesting to see a little bit more of the structure of the vocabulary itself. A graphical interface is another possibility. Also, we are now working, I'm coming back about the type of relations with the broader and narrower, but it is probably also possible to show other type of relations. More RDF defined relations could be shown. Then, besides the graphical interface, I think we are using it as a tool for submission, but I can imagine that people will see opportunities to use it in other environments too. So therefore it's open source code. People can use it, reuse it, work further on it. We will be very happy with that. So the ontology plugin, to give you the names of the students, are Dimitri Surinx, Jeroen, Vaelen, and Niki Vandesbosch, who started in August, and Niki Vandesbosch worked also in January on it still. But I think a lot of input came from Dirk, our software developer, and also from Christophe Dupriez from Destin, who is developing the ASCOSI tool. And more information, you can find more information about AgriOcean Dspace in the first place on AIMS, and about the ontology plugin. You can find the code on Google Code, and you can test the demo site which I showed before on the URL on this page. So that's it about our development about the ontology plugin. I hope you find this interesting. If you have questions, okay, we can discuss.